Okay, so first and foremost, practice guide due tomorrow, right? Test tomorrow in class. It's the same number of questions. What is it, like 9 questions total? The first page is just factor it. It'll be a trinomial in the beginning. Know how to do those. Difference of squares next. Then it'll be a cube rule. Then it'll be a grouping. And then it will be a factor completely where you have to kind of mix some different rules together. Expect that order. Expect the problem you've seen in the homework. That's just what I do. I just pick one that you've already previously done. See if you've actually completed it. Okay, today we're going to start with number 6 and kind of work our way to the end. Now, these first two, 6 and 7, I consider these to be somewhat kind of easy. Because all you have to do is kind of tell me what you're interpreting from the table. These are ones we did in class quite a bit. So you can kind of look back at some of the old videos that we did and kind of see how we did it if you want to go back and watch. But yeah, let's talk about this. This is from the section 1.1 if you want to go back and look at any of those videos. But okay, the first one, you have to figure out which equation represents y1 on that table. So again, you're going to be given a table. I'll take a screenshot of my little calculator and you'll have to tell me which equation works for which one. Okay, so for this one, you are trying to get a -3 for the x when you plug it in, and it will spit out the y1 number. Remember, we're going for y1 on this particular question. Tomorrow, I'll warn you if it's y1 or y2. But we're going for y1. So we want, when I plug in a -3, it spits out 9, and so on and so forth. So, out of these 4, if you've looked at it before, and you plug in your -3, and which ones spit out 9? There's 2 of them that spit out 9. A for sure spits out 9, and what's the other one that spits out 9? B. Not C. C, you have to square the number first, then put a negative sign on it. So it's definitely not C, and it's not D, because if I plug in a -3 there, it gives me like 5 or something like that. So it's A or B. So we're down to 2. So now the next step is just plug in the next number. Plug in a -2. If I plug in -2 here, will that give me, what, 6? Yes. If I plug in -2 in here, will that give me 6? No, so it's letter A, automatically. That's how I narrow it down. You plug in one number at a time, and you see which equation is going to give you the right answer every single time. It's going to be one of the 4 equations that work for every single number for x. That will give out the right y number. Does that make sense what you're doing there? Just plug them in. Pretty easy. You use a calculator, it's pretty straightforward. Okay, y1, the graph. Did it pass through the origin? What is the coordinate for the origin? 0, 0. So does y1 pass through 0, 0? Yes. It has a 0 for an x, 0 for a y. Yes, it did. So you put yes. Move on to the next one. At which points, or point, could be one or plural, does y1 cross the x-axis? So does it have an x-intercept? Now, if you don't know what that means, what it means by crossing the x-axis, it'll have some number and it'll have some 0 behind it. So did it hit the x-axis anywhere in particular? Can you give me one of the coordinates that has some number in the front, comma, 0 behind it?
0, 0.
0, 0. Done. There's one of them. Did it hit any other spot? No, it doesn't look like it. That's the only one. So hit the origin. That's the next intercept. Okay. I don't care. There's a couple. List them out if they have zeros in the back. Does y1 and y2 actually touch each other? Is there any spot that y1 and y2 actually touch? -1, 3. Yeah. So, -1, comma 3. So you can see that -1 gave you 3 for each y1 and y2. So, all right. Questions on your quick things you're going to do on number 6? It's meant to be simple. Like, don't overthink number 6. You were just trying to, answer the questions from the table, interpret the data. It's meant to be quick hitters. Basically, just know your terminology: x-axis, y-axis, origin. Figure out your equation. Something that we've done before. Bless you. Questions with that one? 7. Let's move on. 7's meant to be an easy one too. I give you a picture, and I'll ask you a series of questions about it. So it's going to use the terminology we've talked about in class. So, does this graph have an absolute maximum?
Yes.
Yes. Where? 4, yeah. If you want to tell me the coordinate, you tell me what? -1, comma 4? Kind of roughly. Or you can say the maximum is 4. You can do that, that's fine, I don't mind. Just, whatever you're telling me, just be very clear, and you have to be close. I know that you're interpreting from a graph. It has to be in the ballpark. So I know you could argue with me and be like, it doesn't look like it's really 1 there, maybe it's 1.5. Okay, fine, you're in the ballpark. Okay. You have to be close though. All right, does that make sense for the first one? Maximums, absolute means there's no point higher than that, and that's true on that graph. A minimum would be the lowest point, absolute anyway, and if they're relatives, you could have multiple hilltops or multiple valleys. That's relatives or locals, whatever you want to call them. So just be prepared for one of those. Is this graph symmetric?
Alexander Gabrielson to the office, please. Alexander Gabrielson to the office.
Is this graph symmetric across the y-axis?
No.
No, it's not perfectly centered, right? It's kind of shifted more to the left than it is to the right. So it's definitely not symmetric. If it was, so this is no. If it was, then you have to tell me the type. There's 2 types of symmetry. There's even versus odd. We talked about those in class. This would be an even type of symmetry. It's doing the same thing right and left of the y-axis, like the exact same object. If it's odd, it'll do the same thing on the other side. It'll just be a flip of it. So an odd-based symmetry would be something like this. That's odd-based. If they took the same picture, but went on to the other side and flipped it over, that's how you can tell. That's odd versus even. All right, questions about any of the vocab up till now? Does my graph have any X-intercepts?
Yes.
Yes. Which ones?
-3, 0, 1, 0.
Yeah, -3, 0, and 1, 0. It's good. I like coordinates. Good idea. If you just want to tell me -3 and 1, fine. Just don't put a comma between them. If you tell me -3 and 1, just put like the word and in between, or put a plus sign. Years ago, I had people like, I don't know why they thought this. They actually wrote the numbers like this. That looks like you're writing a coordinate, and that's not even an X-intercept. So don't write it like that. I understand what you're doing, but you don't realize what you just wrote. Okay? All right. Does this thing have a y-intercept? Yes. What coordinate? 0, 3. You can just tell me 3. Fine. Okay, now, the last one. This is the tough one. This is the one that some people just didn't understand the question. So if you look below the graph, you see how they have those little question marks? And I have them listed down below your little question. It says, find the missing value. You are going to the graph, look at your picture, and tell me the answer at that X number. This is your X number that you're plugging into the graph. And I want to know what Y number did it spit out. So if I go to -2, so here's -2 on the X-axis. What answer is it roughly spitting out? 3? Perfect. I'll go with it. If you said 3.5, you're in the ballpark. Does that make sense? You're telling me the Y number you're hitting at that specific X number. You just have to be close, and I mean close. Get as close as you can. Okay, what about 2?
Did you go down -4?
Yeah, so here's 2, and it's all the way down here. What number is that? -5? It missed -4. I know it looks like -4. It actually went below -4. So you have to see right where that point is. You have to kind of follow that line straight down. It's really close though. Okay, questions with what you're doing there? You're just telling me the Y answer at that location. Find the X, go find where the graph was hitting. Just interpret a little bit from the data. Okay, again, they're meant to be quick hitters, nothing like super difficult. It's meant to give you some easy ideas. But the problem is, I think with these questions, it's like, do you even understand what the question's asking for? I think that's where it comes down to. It's not even how difficult the problem is, just what's it even asking for? So I'll try to clarify when we take the test, like, hey, this one's asking for what Y numbers you're gonna hit, and I'll try to do all those little explanations tomorrow. And I try to do that pretty quick, so in the beginning, right when you get your test, really pay attention to the things I talk through. Don't just start and ignore me the whole time. You're gonna miss some kind of important stuff. Okay, but again, expect a new graph. Expect me to ask some basic questions about it. Something you probably did in the homework. Or things we've seen in the notes anyway. Let me scroll down. What are we on, number 8? We have 2 problems left today. I said we're gonna go through these pretty quick and you get some time today, or you can just kind of work on this. Okay. All right, so this question is asking you to graph end behavior, x-intercepts, y-intercepts, if it's symmetric, if it's not, if it has turning points, you know, all that good stuff. You have to make a sketch. There's lots of things I'm checking for. What I want to see, here's what I kind of want to see. I want to see you make a really kind of accurate looking picture. It doesn't have to be perfect, but as close as you can. And then when you're doing these certain things over here, you know, write down what you're doing. So if it's symmetric, like right, yes, it's symmetric, or no, it's definitely not. If it has x-intercepts, list what they are. And then when you go to the drawing, I can interpret what you're trying to do. Because maybe you knew what the x-intercept was, but when you went to the drawing, you completely missed it. And I want to know, I want to see if you knew what you were doing. Maybe it was just a slip of, you didn't realize you missed the x-intercept completely. Okay, so where are my tails going? Up and down, opposites. The reason why, it's a power of 3, right? So the tails are opposites.
Why do you have symmetry on there twice?
Do it? Huh. Didn't realize I did. Typo. My bad. Didn't realize I printed it twice. Huh. I'll fix that for the next one. Didn't realize it. There you go. You can see him typing away, making silly mistakes. All right, so tails are going opposites. This is a traditional odd graph. Tails are probably doing something like that. It's usually up to the right, bottom left. That's usually an odd graph. What would happen if I were to flip the tails? What would make the tails flip the opposite directions? The -3 out front. The -3 would flip those tails. So the bottom left would go up or left, and the right corner would go to the bottom right corner. So they would just flip if that was a -3. Okay. All right, good. So tails are opposite. That explains enough. The graph shows me what you're doing. Okay, what about x-intercepts? How do I find x-intercepts? You have to factor. You will have to factor. This problem will be factorable. I promise you I'll make a problem that is factorable. You can pull it apart. This particular problem, you have to do common factors first, and then you're gonna have to do a trinomial on this bad boy to get this thing to work out. So common factor, what do I have?
3x.
Probably an x, not a 3. They don't all have 3s. But I agree with the x, for sure. Pull the x, so we have 3x squared, 2x, and a -1. If I pull an x from everything. Okay, now we have to factor that trinomial. Now the tough part about the trinomial, the -2 is not made from just the 1 in the back. It's made from the 3 and the 1. It's in combo, the front number and the back number, because the front number is kind of throwing things off. But it's a trinomial rule. What are my symbols going to be? Plus minus. Here's why. It's got the minus sign on the back. It's automatically opposites. That's how trinomials work, right? Minus signs on the back, it's plus minus. Okay, how do you break up the 3x squared?
3 and 1.
3 and 1, 3x and 1x. It doesn't matter where you put them. I'm going to put the 1x here and the 3x here. That's how you break up 3x, right? 3 and 1. There's a reason why I'm putting the 3 in the back, so that I don't get a negative number in the middle. So, what about the 1 in the back? How do I break up the 1?
1 and
1 and 1. And that should work out to make a 2. Now, if you don't trust that, go and FOIL it out and see that it actually does work. This would be 3x squared. That would be a -1x. This would be a positive 3x. That does make 2 then. And then you have the -1 in the back. So it's a lot of trial and error. You have to like kind of break them up and do kind of what you need to. Now, what are my 3 x-intercepts? Because I have 3 on this particular graph.
0.
0 for sure. If there's any variable on the outside, it has to be a variable. Anything that's out there, I don't care if it's an x squared or any other x, it has to be an x of some type, that would be an automatic 0. So you have an x-intercept at 0. I'm going to put it out there. What about this one? -1. Okay. It's really close. Okay. And this one?
0.33.
Yeah. It's positive 1/3. Here's why. No matter what you have, maybe you didn't know this, you always set each one of those equal to 0. That's how I'm doing it. set each of those parentheses equal to 0, and you solve, and it literally tells you what each x-intercept is. That's how I find them out really quick. So if I subtracted the 1 over and divide by 1, I get -1, man. So this one is a -1 for sure, like we did, like I drew, right? The one in the back, if I added the 1 across and divided by 3, yeah, sure enough, I get 1/3. So that's how I'm getting those so quickly. I'm just solving them for 0. And so 1/3, geez, that's really close too. Yikes. They're all kind of close together. That's why it's kind of nice when you can write all your answers out here. You don't need to put everything just on the graph and have me rely on what you're looking at. Because I expect to see that you're doing that type of work on the paper. I don't expect to just see the graph and you're like, oh, it's there, you can see it. Can't you tell? It's 1/3. All right, now, y-intercept. Where am I hitting? 0. How do you find a y-intercept? You plug zeros into everything, into all the x's, and then you solve everything. So it's 0 plus 0 minus 0. Well, that would be, for a y-intercept, that would just be 0. So duh, we already hit the origin. Cool. Okay, so symmetry. Is this thing symmetric? No, it was close. Definitely not. The only reason why it wasn't symmetric, the powers are definitely not all odds or all evens. So that kind of threw it off. It's not symmetric. It was close though. I mean, if you look at the x-intercepts, it was really close to being symmetrical. Turning points. How many times should this thing change directions? Twice? Looks like it should. We're going to pass through each x-intercept. The reason we're not bouncing off of them, each one only happened once. So we're just going to pass through them. Okay, so I think I can make a sketch here. I think I got kind of the idea what we're doing here. We're going to, I'll modify my arrows here. We're going to pass through each one. And the arrows go the opposite direction. So I'm just kind of making my little loops, kind of going through them, dipping and curving. Just very smooth as I go. There you go. That's what I expect to see. I expect to see that you're listing off to the side, you know, x-intercepts, your y-intercept. You know, if it's symmetric, you're going to put what type. This is no, 2 turning points, that type of thing. Like you're listing all the parts you need to do. All right, I do want to see that stuff. Be as thorough as possible. Questions on number 8. 8 is probably the problem that will take you the longest. I honestly think it will. Because you just have to get the parts correct. Maybe 9 will, I don't know. I think 8 will. I think 9's kind of easy. At least the problem I think it is. All right, are we good on number 8? Let's do 9, last one today. We have to do that differential quotient, figure out where the max and min is on a graph. And I will not give you a trick question. I will make a problem that has a max or min. I'm not going to do that weird situation like I did yesterday where I give you number 57. That one didn't have a max or min because it was a line. It didn't even have a curve. So there was no max or min to it. I'll fix them that as a curve. These definitely have curves. I can tell right away that function's a curve. It's a power of 2, so it has a curve. Okay, yeah, we got some work to do here. The good news is I tried to put number 9 kind of in the middle of the page, so you have a lot of room on the bottom to work, and plus you have the whole back you can work on too. I didn't put any problems on the back side, so you have plenty of space to do that problem. So, because I just don't know how much room you take to actually calculate a differential quotient. I have the formula printed. You can see it there. That will be there for testing. Okay. So notice they say h cannot be 0 right away because I can't divide by 0. Later on, you will plug in 0. Later on, at the very end, after you divide every h off, then you plug in 0. So I'm just warning you right now, you can't plug in 0 right away. You have to wait till after you do the differential quotient. That's what the little hint is next to it. I might get rid of the hint for tomorrow, so I don't want to confuse anyone with that little hint. Questions on number 9 before we get started, like what you're looking at. Let me wake up Jada. She's sitting over there. Oh, she's awake. So, all right. So let's plug into my values. So the first step, I got to plug in x plus h in to all my x's. All right. That's plugging in x plus h into everything into the original problem. So wherever there's an x, now there's an x plus h. And then I'm going to subtract the original function off. So that's negative 4x squared plus 4x minus 6, right? And then I'm dividing everything by h. So I don't know how much room that takes you to do, but is there any questions with the setup? The setup is the hardest part for most people. Now, from previous years of experiencing, it comes down to like, I don't know how to set this up. Once I get it set up, then it's fine. Most people can do the work, they can FOIL, they can simplify. You got to get to that point on your own. You take the original function, plug in x plus h's, you subtract the original function off, you divide everything by h, and then you just go to town and start doing all the little math that's involved here. Is there any questions with how I set it up? Seems like you guys had a pretty good handle on this, which is pretty good from previous years. Okay. Foiling this part out, this is an x plus h times x plus h. You do have to FOIL that out before you start. It's the same work we do every time because you have a square there. So I'm just going to leave the negative 4 on the outside. But when I FOIL that thing together, that's x squared plus xh plus xh plus h squared. That's the FOIL of that parenthesis together, the first, outer, and last. Notice I don't do the 4 yet. The 4 will be the last step that I'm going to do. I'll distribute it in later. Okay, questions on that upper left corner. Okay, now so that was just this part. What do I do next? Distribute the 4. Now on this part I can distribute the 4. There's nothing really complicated about that. The minus 6 just hangs out. What about back here?
Distribute the negative.
Yeah, distribute the negative. So it's plus 4x squared minus 4x plus 6. Everything gets that negative sign, so they all change sign in the back. It's all over h. All right. Now I'm going to distribute that negative 4 now because we FOILed those two parentheses together, so now I can distribute. So here's what I have. I have negative 4x squared, negative 4xh, negative 4xh, and a negative 4h squared. So that's that upper left corner after I distribute, right there. Distributing all these 4s to everything, right? And then everything else is 4x, 4h, 4h. We have the minus 6, we have that plus 4x squared, we have the minus 4x, and the plus 6. All over h. Okay, how do you know if you're doing this right?
You can cancel stuff out, everything without an H.
Everything without an h should go away. That's how you know if you're doing this right. So it's like a little safety check. You could stop and go, oh, maybe I FOILed wrong. Maybe I forgot to distribute the negative sign correctly. Things without x's, or things without h's should go away. So like that's gone because it canceled here. 4x is gone because it cancels here. The 6 is gone, that cancels there. Everything that's left had h's on them. That's great, that's what you want. So I have this, 4xh, 4xh, a negative 4h squared, and a positive 4h. Now, what I need to do next is divide everything by the h. So that way that h will cancel out, and you'll be left with a bunch of items. Now there will be one h left in the problem, because when you divide everything by h, this is what happens. The 4x is there, the 4x is here. This h still sticks around. You still have one of them, right? There was 2, you got rid of 1. And then the 4 in the back, that was still hanging out, okay? Questions? Now, in most textbooks, this would be printed in the back. For differential quotients, they kind of tell you, yes, you did it right, there it is. But what do we have to do next?
Set H equals.
Yeah, now you got to do those extra steps to figure out that max and min. You have to plug in 0 for h's. So if I plug a 0 in here, that thing literally turns out to be 0, because 0 times 4 is 0. So that's gone, and I'm left with this. Right, because that 4 is stuck around. But this thing's gone. But then what do? So I plugged in h is 0. Right, that was that first part I just did a little bit ago. H was 0. Now what?
So the equation is 0.
Yeah, so whatever this is, you set that thing equal to 0 and you solve. And that's how you do the rest of the problem. That's how you solve it. You set whatever's left after you plugged in h of 0, and this will tell you where your maximum or minimum is, if there's x's left over. I have x's, so I can solve this thing out. That turns out to be negative 8x plus 4 equals 0. I can subtract the 4 across. And now what? Yeah, divide by negative 8, divide by negative 8. So it turns out my x is half. Fine, it's a decimal, cool, don't care. It could be 0, it could be any random, it could be 1,000 for all I care. As long as you solve for x. Then what do you have to do with it? Plug it back in, into the original problem. So you found the coordinate. This is the coordinate of the max or min on this problem. It was half. I just have to go find the y number. In fact, this problem is actually a maximum. How I know that this is a max on this problem? If you look at the original problem, the tails go the same direction, it's an even power, and it was negative. The arrows face down. So the graph actually kind of looks like that one I had on number 6. If you look back at 6, it actually kind of looks like, or number 7, sorry, number 7. Actually looks like 7's graph, almost. So, but again, you take the half, you plug it back in, and you solve. I'll leave that part for you. You can plug that half back into the original problem. So half squared, it's a 4. Take it times negative 4, add that to half times 4, and subtract 6, and get your decimal. That's fine. Just give me a decimal. Questions? All right. Tomorrow, test, same number of questions, same order. I don't change anything up. I basically just go in the homework tonight, pick out problems we did previously in the homework. I just kind of look back through the homework assignments we did, pick some out, put them on the test, print it out tomorrow. If you know you're going to be gone, let me know. If you have questions, you can always come in after school, before school tomorrow. I'll be here for a little bit. I always have to take my son at 8 o'clock to go to school because they don't open the doors until 8. So, but I'll be back. I'm usually back by 8:03 or 8:04. If you're done with that practice guide and you don't want to lose it, you're like, I'm done, I don't need to study. I'll take it. I'll take it and I'll just start grading it. If you want to hold on to it, cool, it's yours. Hold on to it till tomorrow. That's it for today.